Hey everybody, so in this video we're still going to be solving a systems of equations, and we're still working on one that's going to have three variables. So in this problem it says Jada has 33 coins in her wallet, all pennies, nickels, and quarters. The total value of the coins is $3.41. If the number of quarters is 4 less than the number of pennies, how many of each coin does she have? Okay, so we know that there are three objects in this problem. So we have pennies, nickels, and we have quarters. There's our three variables. So let's let X be the penny. We'll let Y be the nickels. And Z here can be the quarters. Now, they already give you the first equation in the first sentence. See, Jada has 33 coins in her wallet. So if you took all the pennies, all the nickels, and all the quarters, and you counted how many coins you have, you would have 33. So our first equation, we can say X plus Y plus Z is going to give us 33. Then it says the total value of the coins is $3.41. Now, this is something you want to pay attention to, value. What's the value of a penny? A penny is 1 cent. A nickel is 5 cents, and a quarter is 25 cents. So in this problem, we're going to be working with decimals. So if I took a penny and I added the nickels, and then I added the quarters, altogether I'm going to have $3.41. Now, the last equation can kind of be hard to find because they give it to you in the last sentence. If the number of quarters is 4 less than the number of pennies, okay, that's the equation. So the number of quarters, so quarters is Z, Z is equal to 4 less than the number of pennies. So that's the number of pennies, X, some number, minus 4. So this is my very last equation. I have Z equals X minus 4 here. Now, looking at this, it may be difficult to think about how you're going to group the first two and then how you're going to group the last two. Here's something you may want to think about. You already have an equation here that has two variables, Z and X. So really, if I looked at these top two equations, I would want to eliminate the Y variable so that I have another equation with just a Z and an X. So I'm going to do that on the next slide here. All right, so I'll take these two equations and I will try to eliminate the Y variable. So it looks like I'm going to have to multiply the top here by negative 0.05. Now you can do that, or you can multiply the bottom all by negative 20, because 5 cents, that's a nickel, and there are 20 nickels in a dollar. So if you wanted to work with a coefficient of 1, you could do that. But it's probably going to be easier to think about just getting the coefficients the same. So just multiplying everything here by negative 0.05. So here's my new equation. I have negative 0.05x minus 0.05y minus 0.05z. And this is going to equal 33 times negative 0.05. That's going to give us negative 165. So I'll bring down my blue equation here, and I'll have 0.01x plus 0.05y plus 0.25z. This equals $3.41. So now my y's cancel, and I'm left with negative 0.05 plus 0.01. So this is negative 0.04x plus 0.2z equals negative 165 minus plus 341 is going to be 176. Now, here I have an equation, x and a z, and I have this equation, x and a z. So if I wrote that out as a system, so here if I had negative 0.04x plus 0.2z equals 1.76, and then I coupled that with z equals x minus 4. Okay? Now, working with this, if this were our new system, we could easily use substitution. Because we could just take, we already know the value of z. We could just take x minus 4 and substitute that in for z in this equation. So that would look like this. We would have negative 0.04x plus 0.2 times the value of z, which is x minus 4, equals 176. So now we have negative 0.04x plus 0.2x, and then 0.2 times negative 4 is going to be negative 0.8. This is going to equal 176. Now, while this does look strange, it's essentially just a two-step equation with decimals. So I'm just going to combine my like terms here. So my x's, we're just going to combine these. So I'm going to say negative 0.04 plus 0.2, and that's going to give me 0.16. And then I'm going to take this negative 0.8 and add it to the 1.76. So I'll say 1.76 plus 0.8, and that's going to give me 2.56. So now I can say 2.56 and divide that by 0.16, and that's going to give me 16. So here we know that x equals 16. So there are going to be 16 pennies. Z is x minus 4. So if I said 16 minus 4, z here is now going to be 12. So we could easily plug this into the top equation. So I have 16 plus 12, that's going to be 28. What do I add to 28 in order to get 33? And that answer is going to be 5. So remember, your solution has to be an XYZ coordinate. So that's going to be 16, 5, and 12. There are 16 pennies, there are 5 nickels, and there are 12 quarters. All right, that's going to be it for this video. I hope that you found it helpful. If you have any questions, please leave them in the comments, and we'll see you all in the next video. A quick shout out to Gina Wilson. Gina Wilson is the author and creator of this word problem used in this example. I have purchased her products. They are absolutely outstanding. If you are interested in those, you should check her out. She is Gina Wilson, all things algebra. You can find her on Teachers Pay Teachers, Facebook, Instagram, and Twitter.